Welcome back to another section of the Ultimate Django course. In this section, we're going to talk about models which are used to store and retrieve data. We'll start off by a quick introduction to data modeling to make sure you know the essential concepts. Then we're going to design the data model for an e-commerce application. Next, we're going to talk about organizing our models in apps to improve reusability. This is one of the areas that is often misunderstood, so I'm going to demystify it once for all. And then we'll spend the rest of this section encoding model classes. We'll use these classes to store and retrieve data throughout the course. So let's jump in and get started. The first step in every Django project is figuring out the pieces of data we want to store. So what entities or concepts do we have in an e-commerce application? Well, for starters, we need the concept of a product with attributes like title, description, price, and inventory. Now, in a real scenario, a product entity might have other attributes. It really depends on the requirements of our application. For now, we just want to keep things simple, okay? Now, quite often, our products are divided in different categories like shoes, beauty products, fruits, and so on. So we need another entity called collection or category with an attribute called title. Now we need to add a relationship or an association between these entities so we can start from one end and navigate to the other end. For example, we can get a collection and find all the products in that collection, okay? Now, let's assume that in our application, a product can belong to one and only one collection, and a collection can have multiple products. So an asterisk represents many. We could also use an N here, okay? Now we have a one-to-many relationship between collection and product. So relationships can be one-to-one, one-to-many, and many-to-many. Back to our diagram. Now over here, we can add a label called products. And that means when we code these entities or these classes in the collection class, we're going to have an attribute called products. For now, I just want to hide this for simplicity, okay? Now, sometimes we can have multiple relationships or multiple associations between two entities. So let's imagine that a collection can optionally have a featured product. That is the product whose picture we want to show to the user. So we can add a second relationship between these entities. Now look at this number here. 0 to 1 means a collection can have 0 to 1 product, and we're going to call that attribute featured product. So once again, that means in the collection class, we're going to have an attribute called featured product, okay? Now you might ask, what about the ID attribute? Shouldn't every entity have an ID attribute? Yes, but Django is going to automatically create that for us. That's why I haven't shown it here. Now a little exercise for you. Grab a piece of paper and identify the other essential entities we need in an e-commerce application. Just the bare minimum. Don't go ahead and create a complex diagram like this. I don't want this. There are only 5 entities that I want you to identify. So spend a couple minutes and identify these entities along with the attributes and relationships. Then come back see my solution. Alright, so this is what we ended up with in the previous lesson. We have a one-to-many relationship between collections and products. Now don't take this as a hard and fast rule. Maybe in your application, a product can belong to many collections. Then you're going to have a many-to-many relationship between products and collections, okay? So back to our model. I'm going to remove the collection from here so we have some free space on the screen. Now, what else do we need here? Well, in every e-commerce application, we have the concept of a shopping cart, right? So we're going to have an entity or a model or a class called cart with an attribute called created at. Let's assume that we need to know when each cart is created. So every now and then we can do a cleanup and remove carts that are 30 days old. I just made this up, but in a real scenario, you should always design your models based on the requirements of your project. Don't make up your own rules, okay? Now, we need a relationship or an association between products and carts because a cart can have multiple products and a product might be in different carts. So here we have a many-to-many relationship between products and carts. Now, sometimes the relationship between two entities can have attributes. For example, if a product is in a shopping cart, we need to know how many instances of that product we have in the shopping cart. So this relationship itself should have an attribute called quantity. So we're going to add a new entity here called cart item. Now look at the notation I've used to represent this concept. I've connected cart item to the relationship using a dashed line. That means cart item represents the relationship between these two entities, product and cart. This is what we call an association class. So cart item is an association class, okay? Now, there's another way to show this. Instead of using an association class, we can add a relationship between cart and cart item because a cart might contain multiple items and an item belongs to one and only one cart. And similarly, we can add a relationship between product and cart item because each cart item represents a single product and a product might be referenced by many cart items. So here we have two one-to-many relationships between these entities. Now compare this with the association class notation. So we can either add a many-to-many relationship with an association class or two one-to-many relationships. It's a matter of personal preference, okay? So we're done with the shopping cart, but you might ask, what about the user or the customer that owns this cart? Where is that in the diagram? Well, I haven't connected cart with an entity like customer because we don't want to force people to register and log in before they can add products to their shopping cart, okay? So there is no relationship between carts and customers. So carts are essentially anonymous. Anyone can have a cart, whether they're anonymous users or registered customers, okay? So we're done with the cart. Now let's talk about customers. So our customer entity can have attributes like name, email, username, password, and so on. Now, for simplicity, I'm only showing name and email here. Now, a customer can have many orders, and each order belongs to one and only one customer. So we need a one-to-many relationship between customers and orders. Now, once again, the order entity might have multiple attributes. For now, we just want to know when this order was placed, okay? Now, an order can contain multiple products, and a product can be in multiple orders. So we have a many-to-many relationship between orders and products. And similar to the shopping cart example, this relationship itself needs attributes. So here we need another entity called order item with an attribute called quantity. That's our association class. Alternatively, we could add a relationship between order and order item because each order may contain multiple items and each order item belongs to one and only one order. Similarly, an order item references one and only one product, while a given product might be referenced by multiple order items. So two one-to-many relationships. So these are the entities that I wanted you to identify. But to make this project more interesting, I decided to throw in one more entity, tag. Here we have a many-to-many relationship between products and tags. Because a product can have many tags, and a tag might be referenced by different products. We'll come back to this entity in the next lesson. So I told you that a Django project contains one or more apps, and just like the apps on your phone, each app in a Django project provides a specific piece of functionality. So that means each app is going to have its own data model. So in this lesson, we're going to look at a few different ways to organize our entities in different apps. One way is to have a single app called the store and drop all of our entities here. Now, we can bundle and distribute this app via pip, and this way anyone can install this app in their project and get all these models and the functionality around them. So next time we're working on an e-commerce project, we don't have to rewrite the same functionality over and over. We simply install this app in our project and write extra code for customization. Great. But there's a problem here. As this application grows and gets more complex, it gets bloated with too many things, like too many models, too many views, and other stuff. This is what we call a monolith, like a large, heavy piece of stone. So at some point, our application might become hard to understand, hard to maintain, and hard to reuse. It becomes like one of those remote controls with too many buttons. When designing these apps, we want to follow the Unix philosophy. So each app should do one thing and do it well. So here's another solution. We can break down this project into 4 small apps. The products app, which represents a product catalog. So here we're going to have 3 entities: product, collection, and tag. Then we're going to have the customers app for managing customers. We're going to have the shopping cart app for adding the shopping cart functionality, and the orders app for adding the ordering functionality. Not bad, right? Well, this is actually a poor way of breaking down this project for a number of reasons. Look at the coupling or dependency between these apps. The orders app is dependent on the shopping cart app, which is dependent on the products app. So next time we're working on an e-commerce project, we'll have to install all these apps one by one. First, we have to install the products app, followed by the shopping cart app, the customers app, and the orders app. Ideally, each app should be self-contained so we can easily drop it into a new project. The other problem is that if we publish a new version of the products app, that might cause a breaking change in the shopping cart and subsequently orders apps. So anyone using these apps have to upgrade all these apps together. Again, more and more work. Also, it doesn't really make sense to have the shopping cart functionality without having a product catalog, right? Why would we ever want to add the shopping cart functionality to a project without a product catalog? So shopping cart functionality and product catalog always go together. By the same token, why would we ever want to add the shopping cart functionality to a project without the ability to place an order? Just to allow people to add something to their shopping cart? Then what? Again, it doesn't really make sense. So these concepts are highly related and should be bundled together. If we separate them, we increase coupling between apps and we end up with the problems I just talked about. So does it mean we have to go back to the monolithic design? No, there is a middle ground here. Look at the tag entity. The ability to tag products is optional. We don't necessarily need it in every e-commerce application. In fact, we might need it in other types of applications like a blog or video platform and so on. So tagging is not specific to products or an e-commerce application. It's a separate piece of functionality. So I'm going to move the tag entity to a separate app called tags. And here we're going to have another entity called tagged item, which represents an item that is tagged. It can be a product, an article, a video, and so on. It's an abstract concept. Now, with this separation, each app is self-contained and provides a specific piece of functionality. So we can use either or both of them in a new project depending on what we're going to build. Plus, we have zero coupling between these apps, so we can independently change and deploy them without affecting other apps. This is the proper way to break down this project into multiple apps. So here's the takeaway. If our app boundary is so large, we'll end up with a monolith that gets bloated and becomes hard to reuse. On the other hand, if our app boundaries are so small and fine-grained, we'll end up with a lot of coupling between them. A good design is one with minimal coupling and high cohesion, meaning high focus. So each app is focused on a specific piece of functionality and includes everything needed to fulfill that piece of functionality. Okay? So back to VS Code, we're going to create two new apps. So we run Python, manage.py, start app. The first app is store, and the second one is tags. Okay? Now, as I told you before, every time we create a new app, we should add it in the list of installed apps. So let's close this window and go to our settings module. Here's the list of installed apps. I'm going to add those apps right here. So store and tags. All right, we're done with this step. Starting from the next lesson, we're going to create the model classes for these apps. All right, in this lesson, we're going to create our first model class. So let's go to the store app and open the models module. Now on the top, we have an import statement from Django.db, which is a package. We're importing the models module. In this module, we have a bunch of useful classes that you're going to learn about as we go through this section. So over here, we're going to create our first model class. So we define a new class called product and have it inherit the model class in Django. That class is defined in the models module. So models.model. Now here we need to define the fields of this class. What fields do we need here? Well, every product needs a title. So we set title to. Then we go to the models module. Now here we need to choose a field type. So let's take a break here. Now here on Google, let's search for Django field types. Okay, here's the model field reference. We're going to get back to this page over and over. So on the right side, over here, you can see all the built-in field types. For example, we have Boolean field for storing Boolean values. We have char field for storing a sequence of characters, or more accurately, short or medium-sized strings. We have date field, datetime field, decimal field, and so on. So as we go through this section, you're going to become familiar with these field types. So back to our code. We want the title to be an instance of the char field class. Now, all these field types have a bunch of options. So back to our documentation, on the top, look over here, field options. These options are common to all field types. For example, using null, we can determine if a field is nullable or not. We also have DB index. With this, we can create a database index on this field. We can also set the default value and so on. So all these options are available to all field types. Now, some field types, depending on their type, have extra options. So let's scroll down and find the char field. Okay, now read over here. Char field has two extra arguments. We have max length, which is required, and DB collation, which is optional. So using max length, we can specify the maximum number of characters we can store in this field. So here we're going to set max length to, let's say, 255 characters. So this is our first field. Now, in the next section where we talk about migrations, you will see that we can generate our database tables based on the definition of this model. So then we're going to have a table called product, and in that table, we're going to have a column called title, and the type of that column is going to be varchar of 255. For now, let's not worry about this. So that's our first field. What else do we need here? We need a description. That description can be a long text. So instead of a char field, we're going to use a text field. Okay. The text field doesn't have any required arguments. So here we don't have to set the max length. Okay. What else? Next, we need to add the price field. For this, I'm going to use decimal field. Always use decimal field for monetary values. We also have float field, but floats have rounding issues. So for storing monetary values, we should always use decimal field. Now, decimal field, if you look at the documentation, has two required arguments. So as an example, let's say the maximum price we support in this system is going to be 999.99. I'm just making this up. So how many digits do we have here? 6 digits. How many digits do we have after the decimal point? 2 digits. We need to specify these values as arguments here. So max digits equals 6 and decimal places equals 2. These two arguments are always required for decimal fields. Okay. Now let's remove the comment. Another field is inventory. We can set this to an integer field. We also have positive integer, we have small integer, big integer, and so on. And the last field I'm going to define here is last update. Let's say every time we update this product, we want to store the current date time here. So we're going to set this to models.datetime field. And optionally, we can set auto underline now to true. That means every time we update a product object, Django automatically stores the current date time in this field. We also have auto now underline add. With this, only the first time we create a product object, Django stores the current date time here. Okay, so we don't want this. We're done with the definition of the product class. Now a little exercise for you. I want you to create the customer class with these fields: first name, last name, email, which should be unique, phone, and birth date, which should be nullable. So we'll spend a couple of minutes on this and then come back see my solution. All right, here's my implementation of the customer class. So first and last name fields, these are both char fields with a maximum length of 255 characters. Next, we have email, which is an instance of the email field. And here I've set unique to true, so we don't end up with duplicate emails. Next, we have phone, which is also a char field with a max length of 255 characters. And finally, we have birth date, which is an instance of date field. And here I've set null to true, so this field is nullable. Now for birth date, I've used a date field, not a date time field, because we don't care about the time someone was born, okay? Now you might be curious why we don't have an ID field in any of these classes. Because as I said earlier, Django creates it for us automatically. So every entity or every model class is going to have an ID field that is going to be a primary key. But what if we don't want to have an ID field? What if in this product class, we need a field called SKU, and this is going to be our primary key. So we can set this to, let's say, a char field with a max length of, let's say, 10 characters. Now here we can set primary key to true. With this, Django is not going to create an ID field and make it the primary key. So SKU is going to be our primary key, okay? So since we don't need this field for now, I'm going to remove it. Good. So this is how we create model classes. Next, we're going to talk about choice fields. Sometimes we need to limit the list of values that can be stored in a field. For example, here in our customer class, let's define a new field called membership and set it to models.char field with a max length of 1. Now let's imagine in this field, we can have one of these three values. We can have B, that is short for bronze, or S for silver, or G for gold. How can we implement this? Well, let's go back to our documentation. Earlier, I told you that all field types share these options. One of these options is choices, and we use this to specify the possible values for a field. So what we need to pass here is a sequence consisting of iterables of exactly 2 items. Now, I know this is a mouthful. Let's look at a real example. So over here, we have an array of tuples where each tuple includes 2 values. The first value is the actual value we're storing in the database, and the second value is a human readable name. So back to our customer class. Here I'm going to define a new attribute called membership underline choices. I'm using uppercase letters here to indicate that this is a fixed list of values. We shouldn't mess with it. Okay. So we're going to set this to an array. In this array, we're going to add 3 tuples. Here's the first tuple. For the value, I'm going to use B, that is for bronze, and for human readable name, I'm going to use bronze. Now let's duplicate this a couple times and change this to S and silver. And finally, G and gold. Now that we have this array, we can go to our membership field and set choices to membership choices. Okay, like this. Now we can also set the default value. So we can set default to, let's say B, that is for bronze. Now this works, but there is a tiny problem in our implementation. If tomorrow we decide to change B to something else, then there are 2 places we have to modify. Here's one place and here's the other place. So the best practice is to define these values separately. So here we can define another attribute called membership underline bronze. We set it to B. So this is where we store the actual value. And now we reference that in multiple places. So here we use membership underline bronze. And also when setting the default value, we use membership underline bronze. Okay. Now for consistency, we should also define separate attributes for S and G. I'm going to pause the video and do this on my own. All right, here's the end result. We have 3 attributes: membership bronze, silver, and gold, and we have used them here. Now you might be wondering why we need the human readable name. Well, later when we talk about the admin interface, you will see that this human readable name will be used in a drop-down list to populate this field. We'll talk about that later in the course. Now, a little exercise for you. I want you to create the order class with 2 fields, placed at and payment status. Placed at should be a datetime field and it should be auto-populated at the time we create an order object. Payment status should be a char field with these values. So P for pending, C for complete, and F for fail. Spend a couple minutes on this, then come back see my solution. All right, here's my implementation of the order class. So first we have our constants, which are payment status pending, complete, failed, and choices. And then we have our fields, which are placed at, which is a datetime field. And here I've said auto now add to true. So the first time we create an order, Django automatically populates this field. Next, we have payment status, which is a char field with a max length of 1. I've set choices to our array of choices and the default value to payment status pending. So you have learned how to create model classes. Now let's see how we can implement a one-to-one relationship between 2 models. So here in the models module, let's define a new class called address and assume that every customer should have one and only one address, and each address should belong to one and only one customer. So here we have a one-to-one relationship between customers and addresses, right? Now let's add a couple of fields here, like street, which is going to be a char field with a max length of 255 characters. and city with the same definition. Now, as you probably know, a database relationship has two ends, a parent and a child. The parent should exist before we can store the child, right? Now, I've got a question for you. In this relationship, which class or which entity is the parent? It's the customer, because we say the customer has an address. So the customer should exist before we can create an address. So here in the child class or the child entity, we need to specify the parent. So we add a new field called customer and set it to models.one-to-one field. Now, this field has a couple of required arguments. The first one is the type of the parent model. So here we type customer. Now, the second argument is onDelete, and with this we specify the delete behavior. What should happen when we delete a customer? So if we set onDelete to models.cascade, when we delete a customer, the associated address will also be deleted. This is the cascade behavior. Alternatively, if this field accepts null values, we can use setNull. So when we delete a customer or the parent record, the child record, in this case, the address, is not going to get deleted. It's going to stay in the database, and the customer field or the customer column is going to get set to null. In this case, this field doesn't accept null values, so it doesn't make sense to use setNull. Alternatively, we can use setDefault. So this field will be set to its default value. And one other option we have is protect. And with this, we can prevent the deletion. So if there is a child associated with this parent, we cannot delete that parent. First, we have to delete the child. Now, which value we use really depends on the requirements. There is no one size fits all. In this case, I believe we should use cascade, because if we delete a customer, the associated address should also be deleted. Now, there is one more argument we need to set here, and that is primary key equals true. If we don't set this, Django will create another field here called ID. So every address is going to have an ID, and that means we're going to end up with a one-to-many relationship between customers and addresses, because we can have many addresses with the same customer. But if we make this field the primary key, we can only have one address for each customer, because primary keys don't allow duplicate values, right? So this is how we can implement a one-to-one relationship between two models. Now, you might be wondering if we should define the reverse relationship in the customer class. In other words, do we have to go to the customer class and add a new field called address for the reverse relationship? No, we don't have to do that, because Django automatically creates this for us. So we're done with this lesson. Next, I'm going to show you how to implement a one-to-many relationship. Now, let's assume that a customer can have multiple addresses. So we want to change this one-to-one relationship to a one-to-many relationship. How can we do this? Really easy. First, we need to change the type of the field to foreign key. So we're telling Django that customer is a foreign key in this table, okay? Next, we need to remove primary key equals true, because we want to have multiple addresses for the same customer. So we want to allow duplicate values in this column, right? So remove this option. This is how we can define a one-to-many relationship between two models. Really easy. Now it's your turn. I want you to create a one-to-many relationship between these entities. So a collection can have multiple products, a customer can have multiple orders, an order can have multiple items, and a cart can have multiple items as well. So spend a few minutes on this, then come back, see my solution. All right, let's look at my solution. So I've defined a new class called collection with a single field called title. Pretty basic, but note that I have defined this class before the product class so we can reference it over here. So in the product class, we have a new field called collection, which is a foreign key. And this is where we are referencing the collection class defined earlier. Now, sometimes we cannot arrange our code in such a way that the parent class is further up. In those cases, we can pass a string. Just a little tip for you. Now, for the delete behavior, I've used protect. So if we accidentally delete a collection, we don't end up deleting all the products in that collection. Okay? What else do we have here? Here in the order class, we have a new field called customer, which is also a foreign key. And for the delete behavior, I'm using protect. So if we accidentally delete a customer, we don't end up deleting orders. In fact, we should never delete orders from our database because all these orders represent our sales. So they should never be deleted, okay? Now, once again, in this case, I had to rearrange my code. So the customer class is defined before the order class, so we can reference it here. Now, we have a new class called order item with 4 fields. We have order, which is a foreign key to order. And once again, we are using protect here. So if you accidentally delete an order, we don't end up deleting the order items. So if an order has at least one item, we will not be able to delete it, okay? Then we have product, which is also a foreign key. And here we're using protect. So if you accidentally delete a product, we don't end up deleting the associated order items. Next, we have quantity, which I have set to positive small integer field. This way we can prevent negative values from getting stored in this field. And we also have unit price, which is a decimal field. Now you might be wondering why I have defined unit price here. Don't we have it in the product class? Yes, we do. But the price of products can change over time. So we should always store the price of a product at the time it was ordered. Okay. What else do we have here? We have a new class called cart. We could also call it shopping cart. Here we have a single field created at, which is a datetime field, and I've set auto now add to true. So this field gets auto-populated when we create a new cart. And finally, we have a new class called cart item with 3 fields. Cart, which is a foreign key to cart. And here I've used cascade. So if we delete the cart, we don't need it anymore. We should delete all the items automatically. Then we have product, which is a foreign key to product. And here I've also used cascade. So if you can delete a product, meaning if that product has never been ordered before, then that product should be removed from all the existing shopping carts as well. That's why I've used cascade here. And finally, we have quantity, which is again a positive small integer field. All right, let's talk about many-to-many relationships. So I'm going to introduce a new class called promotion and define a many-to-many relationship between promotions and products. So a product can have different promotions and a promotion can apply to different products. So let's define a new class called promotion, which is a new model. Now here we're going to have fields like description, which is going to be a char field with a max length of 255 characters. We're also going to have discount, which is going to be a float field. We can also have start date, end date, and so on. Now we can define the relationship in either of these classes, and as I said earlier, Django will automatically create the reverse relationship. Now in this particular case, it makes more sense to define the relationship in the product class because we might have a product that we're showing to the user, and at the same time, we want to show all the promotions that apply to that product. So I'm going to go to the product class, and over here, I'm going to define a new field called promotions. So we use a plural name here because we might have multiple promotions. Now we're going to set this to models.many-to-many field. And just like before, we need to specify the name of the target model, which is promotion. Now with this implementation, Django is going to create the reverse relationship in the promotion class. So in this class, we're going to have a field called product_set that returns all the products that a particular promotion is applied to. Now, if you don't like this name, you can always change it. So in our product class, where we define our many-to-many field, over here, we can supply a keyword argument related name. If we set this to products, Django will use this name as the name of the field in the promotion class. So instead of product set, we're going to have products. Just remember, if you change the default convention in Django, it's best to change it consistently everywhere. Otherwise, in some classes, you're going to have a field like products, and in some other classes, you're going to have a field like product_set. And this makes your code really ugly. So in this implementation, I'm not going to use related name. I'm going to stick to the default convention. Okay, so this is how we define a many-to-many relationship between two models. Earlier, I told you that sometimes we can have multiple relationships between two models. So here we have two relationships between collection and product. Now, out of the two, we have only implemented the one-to-many relationship. Now, as part of implementing the other relationship, we're going to face a situation called a circular dependency, which is something we should avoid. A circular dependency happens when two classes depend on each other at the same time. So the product class is going to be dependent on the collection class, and at the same time, the collection class is going to be dependent on the product class. So let me show you how to handle this situation. So back in the code, here in the product class, we have this field called collection, which is a foreign key to the collection class. So here we have a dependency from the product class towards the collection class. Now, to implement the other relationship, we have to go to the collection class and add a new field here called featured underlying product, which is going to be a foreign key to the product class. Now, here we're going to set onDelete to, well, if we delete a product and that product happens to be the featured product for a collection, here we want to set this field to null. So I'm going to set this to models.setNull. And that means we should make this field nullable. So here we pass another keyword argument, null equals true. Now look over here, we have an error saying product is not defined. We are seeing this error because the product class is defined after the collection class. Now this is where we have a circular dependency. So in the product class, we have a dependency to the collection class, and that's why we define the collection class before the product class. However, because of the circular dependency, now the collection class also needs to be dependent on the product class, which is not possible. To solve this problem, we need to wrap this in quotes and pass a string here. So this solves our problem. However, this introduces a new kind of problem. If tomorrow we decide to rename this product class to something else, this string is not going to get updated. Let me show you. So we put the cursor here, press F2 to rename product to something else. Let's say product 1. Now look, this string is not updated. So use this technique only if you have to, okay? Now let's rename this back to product. Good. Save the changes. Now let's open up the terminal window. We have an error saying reverse query name for featured product clashes with field name collection. What is going on here? Let me explain. So in the collection class, we have a field called featured product, right? Now, as you know, Django is going to automatically create the reverse relationship for us. So that means in the product class, we're going to have a field called collection, which represents the other end of the relationship. And this is exactly where the problem happens. Because in the product class, we already have a field called collection. So Django cannot create the reverse relationship because of the name clash. So here we have two choices. One solution is to set related name to something other than collection. Or if we don't care about the reverse relationship, we can simply type a plus sign here. This tells Django not to create that reverse relationship. Well, let's save the changes. Look at the terminal. The error is gone and our server has started at this address. Perfect. All right, let's talk about generic relationships. So I told you that we want to design the tags app such that we can reuse it in any project. Anywhere we want to have the ability to tag items. That's why we have two models in this app. Tag, which represents an actual tag, and tagged item, which represents a tag applied to a particular item, which can be a product, a video, an article, literally anything. So let's see how we can implement these models. So back to VS Code. Let's go to the tags app and open the models module. Here we're going to define two classes. The first one is tag, and we're going to give it a field called label, which is going to be a char field with a max length of 255. Nothing new so far. Now the second class is the one that is interesting, tagged item. Now using this class, we can find out what tag is applied to what object. Now to determine the tag, we simply add a field here, tag, which is going to be a foreign key to the tag class. Now here we need to set onDelete to what? Well, if we delete a tag, we want to remove it from all the associated objects, right? So here we're going to cascade. Again, nothing new so far. Now, the interesting part is identifying the object that this tag is applied to. Here's the poor way of implementing this. If we add a field called product, then we need to set this to a foreign key to product. Now, with this implementation, we have to import the product class on the top, and that means the tags app is going to be dependent on the store app. So look, if we say from store.models, import product, now the tags app is dependent on the store app. We don't want to do this. What if tomorrow we want to tag articles or videos? These are completely different apps. So the tags app should know nothing about these models. So delete this line. What we need here is a generic way to identify an object. To do that, we need two pieces of information. The first one is the type of an object, which can be, let's say, product, video, article, whatever. The second attribute we need is the ID of that object. Using these two pieces of information, we can identify any objects in our application, or in database terms, we can identify any record in any tables. Because using the type, we can find the table, and using the ID, we can find the record, right? So instead of using a concrete model like product, we should use an abstract model called content type, which comes with Django. So earlier, we talked about the list of installed apps in the settings module. Let's go there real quick. So over here, we have an app called content types. Using content types, we can create generic relationships between our models. So content type is a model that represents the type of an object in our application. Now, we need to import this on the top. So from Django.contrib, which is short for contribution, then we're going to go to content types app. Then we're going to go to the models module and import the content type class. So this is a model just like any model that we have in our application. But this model is specifically made for allowing generic relationships. Now, back to the business. So we're going to have a foreign key to content type, and that means instead of product, we should call this field content type. Now, for onDelete, once again, we're going to use cascade, because if that object type is removed, we want to remove all the associated tags. So models.cascade. Now, the second attribute we need here is the ID of that target object. So we can call this field object underline ID, and this has to be a positive integer field because we're assuming that every table is going to have a primary key and all primary keys are positive integers. Now, what if in a particular table, our primary key is not an integer? Let's say it's a GUID. Well, this solution is not going to work. So this is the limitation of this solution. So now, with these two pieces of information, we can identify any object in our application. Now, one last thing. When querying data, we might want to get the actual object that this tag is applied to, like the actual product. To do that, we're going to add another field here called content underline object. And of course, we could call it anything. Now, we should set this to a particular type of field called generic foreign key. Now, we need to import this on the top. So I'm going to duplicate this line and change models to fields and content type to generic foreign key. Now, using this field, content object, we can read the actual object that a particular tag is applied to. So let's quickly recap. To define a generic relationship, there are three fields we need to define: content type, object ID, and content object. Now a little exercise for you. I want you to create an app called Likes for tracking the objects that a user likes. So in this app, we're going to have a model called liked item. And using an instance of this model, we can tell what user likes what object. So here we need a field called user, which is going to be a foreign key to the user class defined in this module, django.contrib.auth.models. So auth is another app that is automatically installed in every Django project. And using this app, we can authenticate and authorize users. So go ahead and spend a couple minutes on this, then come back see my solution. All right, here's my solution. We have a new app called Likes, and in this app, we have a new model called liked item. Now here we have 4 fields. We have user, which is a foreign key to the user class defined in Django.contrib.auth.models. Now here for onDelete, I've used cascade. So if a user is deleted, we want all the objects that the user has liked to be deleted as well, okay? Then we have 3 fields exactly like before, no changes. So we have content type for identifying the type of an object that the user likes. We have object ID for referencing that particular object, and content object for reading an actual object. So that was pretty simple. Let's move on to the next lesson.